Alright, so just to correct a previous error that I made, I remember saying in a previous video that when I went from 1 milli for the rise time to 1 nano that I had changed 3 orders of magnitude. That's actually 6 orders of magnitude. I was confusing milliseconds for microseconds. In this video, I'm actually going to make my um, delay time 1 microsecond because we're going to be changing over to an inductor. So let's change this value to VL. Actually, I'll make that a capital L so it's more obvious. I'll delete my capacitor and let's throw an inductor in here. One of the more annoying things about LT Spice is if I place an inductor here, there's extra wire. The capacitor symbol is actually smaller than the inductor symbol. So you actually need to move the ground down so that it fits. One of the more annoying things about LT Spice. But I'm going to go ahead and make this a 1 millihenry inductor, and if you recall, the L over R time constant, tau for an RL circuit, is L divided by R. 1 milli divided by 1K gives me 1 micro. So I'm going to be operating in microseconds. I'll change my transient sim to a 10 microsecond sim rather than 10 milliseconds. And again, we're going to go ahead and just observe the RL behavior that we saw in lecture, but we're going to go ahead and observe it in LT Spice. And so if I wanted to go even lower, if I wanted to go down by the same amount for rise and fall time on my pulse, I could go down into the picosecond range rather than nanoseconds. I don't think it's going to matter. The 1 nanosecond would have been plenty fast, but let's just stay consistent. So now I'm at 10 to the minus 6 seconds for my delay time and 10 to the minus 12 seconds for my rise time and fall time for this pulse. Okay, so let's go ahead and run it and see what happens. We are going to zoom in on this a little bit and then let's blow this up. Look at our source voltage. Let's look at what happens to my inductor voltage. Yep, it jumps up and then bleeds off back to 0 because in DC an inductor is a short circuit. Can add a plot pane, and we know that an energized coil has current flowing through it, so let's go ahead and see what happens to the current through my inductor. And we see that it charges up with an exponential the same way that capacitor voltage charges up. That's the same way that our inductor current charges up, or the same way that our inductor is energized by current is the same way that our capacitor is energized by voltage. Okay, and we can see that that's the same current flowing through my resistor. If I were to add another plot pane, I could actually see that they're identical because they're in series, which is exactly what we expect. Okay, and so this is our charging, or sorry, our energizing a coil LT Spice example. If I wanted to de-energize the coil, I would just go ahead and swap from 5 over to 0. And then I can go ahead and run, and I get the discharging or de-energizing behavior that I would expect for my RL circuit. Okay, so I'm going to go ahead and end this video here, but just wanted to kind of do the same things we did for RC circuits in the context of an RL circuit just to show it in LT Spice.